In this video, we're going to get an introduction to two basic styles of forecasting methods, but more importantly, what we want out of this video is how we measure how accurate our forecast is. Okay, so first we'll deal with this set of data and do a naive forecasting method, followed by a forecasting method based on the average of all historical data. We'll calculate the measures of forecast accuracy, and then we'll determine which of the two methods is the more accurate forecasting model. So first, the naive method. The naive method of forecasting is the most absolute basic model of forecasting we can use. It is simply predicting future sales on what happened in the period immediately prior. In order to begin our forecast, we cannot predict for period 1 because we don't have any sales prior to period 1. So remember, at the time we would have made this period 2 prediction, we wouldn't have had any of this information. All we would have had is our weekly 1 sales in this case, and use week 1 to forecast what was going to happen in week 2. Similarly, now that week 2 is done, we now have sales for week 2. We can go and predict what's going to happen in week 3. And we could have done that all the way along. And because I have sales for week 12, I could actually predict what would happen in week 13. So if I was to predict in this case what my sales for week 13 were going to be, I would say that this gasoline distributor is going to sell 5,810 liters in period 13. That would be my prediction. Once we have the forecast set, which we do now, and as I said, that is the most basic forecasting method we can use, we can go ahead and calculate various measures of forecast accuracy. The 3 that we're going to look at are referred to as MAE, which stands for mean absolute error, MSE, which stands for mean squared error, and MAPE, which stands for mean absolute percentage error. The 2 that we really want to use to determine how accurate our forecasts are firstly, mean squared error. The mean squared error we'll use to compare when we're looking at forecasting models that are looking at data that sort of falls within the same scale. So here we're dealing with thousands of liters, and as long as we're dealing with other variables that deal with this same sort of scale, we're okay. But if I was looking at this company dealing with thousands of liters, comparing it to another company that sells millions of liters, naturally the error will increase as I increase the numbers that I'm talking about. So when we're talking about different scales of data, we've got one set of data that's in thousands, another that's in millions. If I want to try and compare what the more accurate forecasting model is, it might be better to use the mean absolute percentage error, because that one will always calculate the error as a percentage of the values that we're dealing with. Whereas the squared error will naturally inflate higher and higher if we're dealing with bigger and bigger numbers. So really the real 2 that we want to talk about in terms of which forecasting method is going to be the best are these 2. But we calculate mean absolute error because both MSE and MAPE are both based on the MAE anyways. So we'll start determining our forecast accuracy by first determining our absolute error. So I cannot determine what my error is in period 1 because to determine the error, it's really comparing what did we sell compared to what did we forecast we were going to sell. Well, without a forecast, it's impossible to calculate the error. The first point where we can make a calculation of the error would be in week 2, where we do have actual sales and projected sales. But again, notice that we want the absolute error. So we want the absolute value, or the Excel function, ABS, of our week 2 actual sales minus our week 2 predicted sales. And because I cell reference, I can copy and paste that formula down all the way to week 12, where again is the last place where I have actual and predicted sales. Right? For week 13, we only have predicted sales. So the reason why we use the absolute error here is because if I was doing that subtraction, sometimes my forecast will be on the high side, sometimes it'll be on the low side. And if we're looking at some values being positive and some being negative, those two things are going to kind of cancel each other out and will give us a false representation of how accurate our forecasting method is. That's why we'll always use the absolute error. So in order to determine MAE, or the mean absolute error, I would simply take the average of those absolute errors that we just calculated into 2 decimal places. We would get MAE of 0.98. Similarly, in order to calculate the squared error, well, since we already have the error itself calculated, all we need to do is to simply square this value. Square all those absolute errors that we just calculated. And again, because I saw reference, I can simply copy and paste that all the way down, calculating the error from periods 2 to period 12. So those are all of my squared errors. To calculate the mean squared error is again simply just taking the average of those values, hitting enter into 2 decimal places. We get MSE of 1.13. Our final measure of forecast accuracy is the absolute percentage error. And this one we have to be careful, as anytime we are calculating a percent, we need to know what we're using as the appropriate numerator and denominator. So we want to involve our error. Now remember, this is always based on what actual sales are. We want our error as a percentage of what the actual sales were for that time period. So I'm going to divide my absolute error for period 2 by the actual sales for period 2. So in period 2, we had a 19.1% error. Again, we would do that for each and every period in which we have both actual sales and predicted sales, and then calculate the average of those values. So absolute percentage error, typically displayed as a percentage, so we have an MAPE of 19.22%. So we now have our 3 measures of forecast accuracy, MAE, MSE, and MAPE. The 2 main ones, which we would use as a comparison between different forecasting methods, MSE and MAPE. MSE, if our data is in the same scale. MAPE, if we're looking at data sets that differ in scale. So 1 in hundreds, 1 in thousands, 1 in millions, because MAPE will always calculate the percentage error as a percent of the scale within that data set. So MSE, if I'm looking at 1 in hundreds, 1 in thousands, the 1 in hundreds would always have a smaller mean squared error. So let's look at our second forecasting method and determine which of the forecasting methods will give us a better prediction for week 13 based on how our forecasting accuracy measures turn out. So in the next example, we're asked to forecast based on the average of all available historical data. So again, all our forecast measures are based on first calculating a forecast. So this is the exact same data set. If I go back to the example we just did, we're still dealing with that gas distributor in London, Ontario. Once again, we cannot predict for week 1 as we don't have any actual sales. We can first begin by predicting for week 2. And this method begins in the exact same way our last method did. If I'm looking at the prediction for week 2, well, it's the average of everything that happened before that. Well, the only thing that's happened before it so far is our period 1. So week 1 sales will provide our forecast for week 2. But now when we go into week 3, our week 3 forecast is going to be the average, again, of everything that happened before that. So periods 1 and period 2. But if we think about what we want in the future, if I want to copy and paste this along, if I just hit enter now and I copy and paste that formula down, what's going to happen, and again we'll predict all the way to period 13. If I do that, so in period 3, it appropriately used the average of everything that happened before that. However, in period 4, it only used the average of the prior two periods because every cell reference I made in the first formula was moved down one space as I copy and pasted. Well, what we want to make sure we do is that we don't want period 1 to move. So for period 3, we wanted it based on periods 1 and 2's average. For period 4, I want it based on 1, 2, and 3. For period 5, 1, 2, 3, and 4. So in our formula, we always want that first cell to stay as period 1. So our first cell reference needs to be an absolute reference. So I'm going to absolute reference my period 1 sales. We do want the second cell reference to move, however, because that cell reference I do want when I get down to period 4. I want that now to be periods 1, 2, and 3. So if we look what happened by simply absolute referencing that first cell, and so now if I look at period 3, again it still did the appropriate first two periods. If I look at what happened in period 4, so because I absolute referenced my first period sales, that first cell reference stayed, whereas the next one, not absolute reference, moved down. It did give me a prediction of the average of everything that transpired before that. And by the time we get down to week 13, what we're going to try and predict for, we see that the week 13 prediction is the average of all the sales that happened in weeks 1 through 12. So now we need to determine our three measures of forecast accuracy, MAE, MSE, MAPE, beginning with our absolute error. So again, we cannot calculate absolute error in the first period. We don't have forecasted sales. This would be the absolute value, or the Excel function ABS. Actual sales minus forecasted sales. Copying and pasting that down all the way to period 12. And again, we can't do it for period 13. We don't have actual sales for period 13. Finalizing it by calculating the average of all those absolute errors. And to two decimal places, we get MAE of 0.64. Calculating the squared error, simply squaring the absolute errors that we just calculated. Always cell referencing to make our work easier. Finishing it off, MSE, simply the average of all of those squared errors. And once again, to two decimal places, we get MSE of 0.57. Last but not least, the absolute percentage error. And remembering absolute percentage error, the numerator will always be the error itself, or the absolute error, divided by actual sales. So for periods 2 through 12, and then calculating the average of all those absolute percentage errors, we get MAPE to two decimal places of 12.82%. So those are all our measures for the average of all historical data. If we compare that to our three measures when we did the naive forecasting method, with the naive method, we got measures of MAE of 0.98, MSE of 1.13, and MAPE of 19.22%. So comparing all three measures, we can see that whichever one we use as our measure of forecast accuracy, all three measures are better for the average of all historical data. Typically what we would use, because we are talking about the same scale of the data, it's the exact same data, we would use the measure of MSE as our preferred measure of forecast accuracy. So based on the fact that we have a better predictive model with the average of all historical data, looking at part D, which forecasting method used for 1A or B provides a more accurate forecast, it is definitely the average of all historical data, which means in order to predict for week 13, I would prefer to use the forecasting method of the average of all historical data, and I would say that the predicted sales for week 13 would be approximately 5,086 liters of gasoline.